Morning class, this is the lecture for 8B. This is the last section that is on test 3. The quiz for 8A and 7E will be on Wednesday and I'll send it out. If you don't get it, please email me. There's been a breakdown in Blackboard. So, we're going to talk about doubling time. You've all made bread, or you know the concept of making bread. You start out with a certain amount of yeast and flour and egg and water, and then you let it rise, and then it doubles. And you let it rise more, and it doubles again. This is kind of like the chessboard. So what we have here is a doubling time of 2 hours. In other words, every 2 hours the amount doubles. So we start with 10 grams of something. And 2 hours later, so this is 2 hours later, we have 20 grams. And 2 hours after that, we have 40 grams. And 2 hours after that, we have 80 grams. Be careful not to say 60. 80 grams, okay? So what we're going to do is figure out not at exact hours, 2, 4, 6, 8, but at 11 and a half hours or 14.3 hours, okay? You know, nothing is that simple. Okay, so here is the formula that we're going to start with, okay? And now I'm going to do some problems from your book, just so you can follow along. Okay, right now we have the new amount is equal to the initial amount times 2 for the doubling to the little t power over the big T power. Now this is the most common mistake. First of all, those have to be in parentheses. Okay? But the little t is how long you run the experiment. And big T is the time it takes for your substance to double. So if this would be the 2 hours for doubling, and this is how long it takes for me to run my experiment, 14.3 hours or something like that. So let's do an example. How much are you going to have if you start with 15 grams of something, meat, no, not meat, flour and butter and water and yeast, okay? And the time to double, capital T, is 3 hours. So in other words, every 3 hours, your substance doubles. And I'm going to run my experiment, little t, for 14 hours, okay? So the starting amount is my initial amount. So I'm going to say 15 times 2 to the little t on top, 14 over 3, okay? So, you know, this has to be in parentheses because it's a two-piecer. Now, we haven't talked that much about order of operations, but I certainly hope that no one is going to go 15 times 2 is 30, because that would be wrong. You're going to punch it in exactly like you see it. 15 times 2 to the parenthesis 14 divide 3. Okay, and I'm going to have my assistant hand me my calculator so I can do that with you. Thank you. Okay, so I punch it right in. 15 times 2 to the 14 divide 3, close parenthesis, is 380. Oh my goodness, it really grew. New equals 380 0.97625. Okay, so suppose I said to round to the nearest hundredth. So here's the hundredth. You would look at that 6, and you know that that makes that 98 grams, 380.98. Okay? So what I expect to see is your work, your substitution into the formula, and then your answer. Okay? So that is the full-blown problem. I'm erasing. Okay. Now there's a couple of smaller little things that people always find interesting. Okay. This is your number 38. These problems are kind of out of order. I think the second set of problems, it really should be the first. Your number 38 says, a city population is growing at a rate, so that tells you it's a doubling problem, growing at a rate of 2.5% per year. Okay? First question. What is the doubling time? Okay? Okay? Well, in this problem, the capital T, you already know the doubling time. This problem is asking you to find the doubling time. And this is a really handy dandy little formula. The time to double, okay? The formula is 70 divided by the percent stated per time period. Okay, now this is the only time that you're going to be with me where you put in the actual percent. We're going to put 2.5 right there. Okay, now what we're finding is if it grows by 2.5% per year, how long is it going to take for it to grow 100%? To go from 1,000 people to 2,000 people if it only increases 2.5% per year. So we have this, and we're going to say, okay, 2.5%, that's going to be 70 divided by 2.5, and we don't put the percent. We go 70 divided by 2.5, and that gives us 28. Okay, it's going to take 28 years for the population to double, to go from 1,000 to 2,000, or 10,000 to 20,000. Okay, this is a really nice little formula. Unfortunately, this is the only thing it does for us. But this formula is also used in physics and chemistry and finance and accounting. It's called the rule of 70. The rule of 70. Okay? That's where you put the full percent. You don't change it to a decimal. Okay? Actually, it's not really 70, it's really 73, but it's done at 70 so you can do it in your head. Okay? So, the rule of 70 is a pretty cool little item. Okay? So, for instance, it takes, the doubling, find the doubling time for a substance that grows by 6% a week. So 6% a week. Okay? So I start out with 100 centimeters or grams or kilograms or whatever, and 1 week later I've got that original 100 plus another 6%. So starting week 2 I have 106, and that's going to double to 212. Okay, but how long is it going to take for the original amount to double? Okay, so I use my rule of 70, and I divide it by 6. Okay? And that gives me 11 point some 267 weeks. Okay? You have to include your time frame, right? So that's 2 of the formulas. The third formula, okay, is even simpler than this one, and it is called the factor formula. Okay. So I'm going to go back to my original formula. See right here? The factor part is inside that formula. Factor. The factor is just 2 to the little t over big T, okay, with parentheses here. Now the factor formula omits the initial part, okay, and the new part, and it just says by what factor is it going to grow. So let's just say that little t is equal to 5 and big T is equal to 8, okay? So the factor would be 2 to the little t over big T. And that's the answer. How hard can that be, all right? So, why would you use this? Well, I started my experiment with 100 grams. So then I can just multiply my 100 by that factor. You started your experiment with 150 grams. So you would just take your 150 and multiply it by that factor. Someone else started it with 10,000 grams, and they just take it and multiply it by this factor, okay? Let me get one problem in here, and then I'm going to pause and start part 2, which will be a second example. All right, so your number 30 says, the initial population of a town is 5,000, and it grows with a doubling time of 8 years. What will the population be in 12 years? Okay, the initial population is 5,000. The doubling time is 8 years. What will it be in 20 years? That's little t. So, what will it be? The new amount is equal to the initial amount times little t over big T. And the answer to that one, you should do it for yourself, is 14,142 people. Okay? I'll be back in a minute.